Welcome. This is Crystal. We are going to learn about Chapter 3 Solids, Liquids, and Gases. For ease of understanding, I have divided this chapter into 3 sections. First section is about states of matter. Second section describes change of state of matter. And the third section is about the behavior of gases.
Hi, this is Mike. I am going to explain about first section called states of matter. The states of matter are the physical forms in which a substance can exist, and it determines how fast the particles move and how strongly the particles are attracted to one another. For example, water can exist as a liquid in the form of water, solid in the form of ice, and a gas in the form of steam. The 4 states of matter are solid, liquid, gas, and plasma. Plasma state we can find on Sun and other stars, but on Earth does not occur naturally. Now we are going to discuss about each of the state in detail. Let's start with solids. A solid has molecules that do not move fast enough to overcome their attraction to one another. Therefore, molecules are packed closely together. Solids can only change their shape by force. A solid has a definite shape and volume. The 2 categories of a solid are crystalline solids and amorphous solids. In crystalline solids, the particles are packed in a regularly ordered, repeating pattern. Examples are diamond, iron, and ice. Amorphous solids have atoms or molecules in no particular order. Each particle has a spot, but the spots are randomly scattered throughout the structure. Examples are rubber and wax. Let's come to liquids. A liquid has molecules that move fast enough to overcome some of their attraction, but not completely. As a result, liquid flows. So it has no definite shape, but have definite volume. Now, we will learn about properties of liquids. Liquids have a surface tension and viscosity. First, we will learn about surface tension. Surface tension is the force acting on the particles at the surface of the liquid that causes the liquid to form spherical drops. Now we will move to viscosity. Viscosity is a liquid's resistance to flow. For example, honey pours very slowly from a jar, while water is very fast. This is because the molecules in honey have a much stronger attraction to one another, and the water. While with a liquid that has particles moving, but close to one another, it is going to have a more solid-looking appearance. Thus you have honey. So we say that honey has a higher viscosity and thus pours more slowly. Now, we are going to learn about gases. A gas has molecules that move fast enough that they are able to overcome nearly all of the attraction between one another. Gas molecules are able to move independently of each other. Thus, a gas has neither definite shape nor definite volume. To get more clarity about gases, let's see one example of balloon. When you fill a balloon with helium gas to a certain size, the particles will spread out and fill the space. If the balloon is about 8 inches in diameter, the particles will be somewhat close together. Now, increase the amount of helium in the balloon. Not only does the size of the balloon change, that is change of shape and volume, but the distance between the particles will increase as well.
Hi, this is Kate. We are in second section called change of state of matter. A change of state is the conversion of a substance from one physical form to another. Let's start with changes between solid state and liquid state. First we will see solid to liquid. When you heat solids they melt and become liquid. This is called melting. Different materials melt at different temperatures. This is called melting point of that material. Melting point of water is 0 degrees Celsius. This is when ice, which is solid, becomes liquid. Now we will see state change from liquid to solid. Freezing is a phase change in which a liquid turns into a solid, when its temperature is lowered below its freezing point. All known liquids, except liquid helium, freeze when the temperature is lowered enough. Liquid helium remains liquid at atmospheric pressure even at absolute zero, and can be solidified only under pressure. Now we will move to state changes between liquid and gas. Vaporization is the change of state from liquid to gas. Vaporization can occur in two ways, that is evaporation and boiling. Evaporation is a phase transition from the liquid phase to gas phase that occurs at temperatures below the boiling temperature at a given pressure. Evaporation usually occurs on the surface. Boiling occurs at or above the boiling temperature. Change of state from gas to liquid is known as condensation. Condensation occurs when particles in a gas lose enough thermal energy to form a liquid. Now we move to changes between solid and gas. Change of state from solid to gas called sublimation. During sublimation, particles of a solid do not pass through the liquid state, as they form a gas. An example of this process is dry ice. It is a solid block, but as it melts it does not turn it to a liquid, but rather a gas. The process of a gas changing directly into a solid is called deposition or desublimation. For example, water vapor in sub-freezing air can transform into ice without going through the liquid phase, which is how snow and frost are formed.
Hi. This is Paul. We are in third section called the behavior of gases. When working with a gas, it is helpful to know its volume, temperature, and pressure. Temperature is a measure of the average energy of the motion of a particular matter. Volume of a gas is same as its container. Pressure is the amount of force exerted on a given area. The system international unit for pressure is the Pascal. Pressure is equal to force by area. The relation between pressure and temperature. When the temperature of a gas at constant volume is increased, the pressure of the gas increases. When the temperature is decreased, the pressure of the gas decreases. Charles found that when the temperature of a gas is increased at constant pressure, its volume increases. When the temperature of a gas is decreased at constant pressure, its volume decreases. A graph of Charles' law shows that the volume of a gas is directly proportional to its Kelvin temperature under constant pressure. Boyle found that when the pressure of a gas at constant temperature is increased, the volume of the gas decreases. When the pressure is decreased, the volume increases. A graph of Boyle's law shows that the pressure of a gas varies inversely with its volume at constant temperature.
With that, we come to the end of the chapter. This narration was presented by SchoolinMobile. Please visit us on the website SchoolinMobile.com.